On April 12, 1961, when Yuri Gagarin made his first spaceflight, Soviet scientists were faced with an unexpected question: what and how to feed a person in zero gravity? It turned out that ordinary terrestrial products behave unpredictably in space. Crumbs fly around the ship, water collects in balls, and sandwiches are simply impossible to hold in your hands. This is how the history of space nutrition began. A fascinating epic of scientific experiments, culinary discoveries, and unusual gastronomic solutions. In this video, we will tell you how Soviet space food was created, what cosmonauts loved, and what unusual problems the engineers and cooks of the space kitchen had to solve. The first meal in space was extremely modest. Yuri Gagarin took with him only 3 tubes of 160 grams, 2 with meat puree, and 1 with chocolate sauce. Drinking water, about 300 ml, was placed in a special cylinder with a straw. Interestingly, before the flight, no one was sure whether a person would be able to eat and drink in zero gravity. Gagarin successfully refuted these fears. During the flight, he ate twice, proving that digestion in space works normally. However, real space cooking began later, when the flights became long and the issue of nutrition came to the fore. Soviet engineers quickly realized that ordinary dishes are useless in space. This is how the famous tubes with space food appeared: light, airtight, and safe. They were made of aluminum and later of multi-layer laminated film. Homogenized products were placed inside, which did not crumble or delaminate in zero gravity. Interestingly, the first tubes resembled toothpaste, and cosmonauts had to squeeze the food directly into their mouths. Later, more convenient options with valves appeared. In the 1970s, the assortment included dozens of items, from borscht and rasolnik to cottage cheese with prunes. Space caviar was especially popular. It was even taken into orbit as a delicacy. It turned out that many terrestrial products are absolutely unsuitable for space. For example, bread quickly crumbled and its particles clogged the ventilation. A solution was found in the form of miniature loaves for 1 bite. Each piece was packed in individual film. Salt and pepper had to be made liquid, otherwise the spices flew around the cabin and irritated the eyes. Interesting fact, cosmonauts complained that in zero gravity, food seemed less tasty. This is due to the fact that in zero gravity, the nasal mucosa swells, dulling the sense of smell. Therefore, Soviet scientists specially enhanced the taste and aroma of space dishes. One of the most difficult challenges for space cooks was to adapt borscht to zero gravity. A regular soup with chunks of vegetables and cabbage was impossible. Liquid and solid particles behaved unpredictably. After long experiments, they created a homogenized borscht puree that did not separate and was easy to squeeze out of a tube. Interestingly, borscht was the first real dish that Soviet cosmonauts tried in orbit. Before that, food was more functional than tasty. In the 1980s, the menu was expanded to 300 items, including even such complex dishes as chicken in sauce and mashed potatoes with onions. All meals for cosmonauts were developed in a special research institute of the food concentrate industry. Each product underwent a rigorous selection. It had to retain its taste and nutritional value for at least 18 months, not require special storage conditions, and, of course, be safe. Interestingly, space food was initially tested not only by tasters, but also test pilots. They spun in centrifuges and performed complex maneuvers, checking whether the food would cause nausea. Particular attention was paid to caloric content. The daily diet of a cosmonaut was about 3,000 kcal, with 40% of this being protein. Many technologies developed in the USSR are still used in space nutrition. For example, tubes of puree remain the standard for liquid dishes, although they are now made from modern materials. But freeze-dried products, which were originally created for the military, were a real breakthrough. After adding water, they restore the taste and texture almost like fresh ones. Interestingly, some space developments have migrated into everyday life. For example, baby food in soft packages or instant cereals. Today, Russian cosmonauts on the ISS receive about 450 types of products, including even fresh fruit. But the basis of the diet is still based on Soviet developments. Another fascinating detail is how meals were psychologically tailored to keep morale high during long missions. Soviet scientists understood early on that food wasn't just about nutrition, it was comfort, familiarity, and a crucial factor in mental well-being. That's why they worked closely with cosmonauts to include personal favorites on the menu. For instance, some requested specific soups or desserts reminiscent of home. Even the packaging was carefully designed not just to withstand zero gravity, but also to feel intuitive and human-friendly. Cosmonauts were also trained on how to eat in space, using magnetic trays and Velcro-fastened cutlery to keep everything from floating away. These innovations reflected not only engineering ingenuity, but also a deep understanding of human needs in the alien environment of space. Today, the legacy of Soviet space food lives on, not just aboard the International Space Station, but in how we think about nutrition in extreme environments, from polar expeditions to future missions to Mars. What began as an experiment with meat paste in aluminum tubes has evolved into a complex science involving taste psychology, microbiology, and food engineering. As space agencies plan longer missions beyond low Earth orbit, the challenges grow. How to produce fresh food in space, how to recycle waste, and how to keep astronauts healthy for years away from Earth. But one thing is certain, the pioneering work of Soviet scientists laid the foundation. Their innovations, born from necessity during the Cold War, have quietly shaped the future of food in space and even influenced what we eat here on Earth.